Imtiaz, first question to you. Okay, research. What have you seen this year that's gonna amaze us going forward?
So, Irene, of course, this has been a challenging year for many of us due to the coronavirus pandemic, and we've realized how reliant we are on digital in this era. And indeed, I believe that trend, that acceleration to digital is going to continue going forwards, even post-pandemic. And what we have seen is we're coming to a world where increasingly, and especially as we get convergence with 5G and edge computing going forwards, that we're going to shift more and more towards bringing AI, machine learning, deep learning onto the devices all around us, which is going to mean changes in the way we've done things. We're going to move away from some of the powerful deep learning techniques, such as recurrent neural networks and convolutional neural networks that have been dominating and have been very powerful in the social media world and the big data of the e-commerce giants, towards an era where we get to networks that can work on smaller data and are more computationally efficient, which is also good for the environment and climate change, but also better for battery life and low resource environments on the devices around us. With that in mind, what we've seen is the rise of transformer networks. They've already had a huge impact in natural language processing, and of course GPT-3, which gained a lot of attention this year, is a transformer-based model. But not only in NLP, we're also seeing the likes of Facebook research combining convolutional neural networks with transformers for computer vision. They created something called the DETR for end-to-end computer vision. It's actually very easy to use and work. I've applied it myself. And that actually reduces the computational complexity, or computational cost, I should say, of computer vision, because one of the challenges, as George will be aware, is getting the big data sets. And that's been a challenge when we've gone outside of social media and outside of the big e-commerce giants to scale deep learning in the real world. We see lots of startups come in, get money, but then they struggle to scale in area because getting the access to the data has been a challenge. So to really scale deep learning across the real economy into other sectors of the world, or we needed these advancements. And so transformers have gone a step further, because in October of this year, an anonymous paper, which later turned out to be Google, applied transformers without any convolutions to image recognition. And the likes of Andrew Karpathy, who's head of AI for Tesla, and others out there were really amazed at the results. A leading DeepMind researcher said, farewell convolutions. We'll see if that actually replaces convolutions or not. It's still in its early days, but it's showing a lot of promise that to actually replace these networks, which is quite a fundamental change. Transformer networks were believed to also have played a role in AlphaFold, which was the work by DeepMind to solve for protein folding, a 50-year-old problem. And then, of course, more recently, we've also seen MuZero, which has been under development for a while. There's been reports on it going back a year ago, but recently, in the last week or so, Google provided an update, or DeepMind, I should say, provided an update. And it's very exciting because it's showing that it's an evolution, or quite a revolution, which we could even say, going from the AlphaGo, which beat the world champion in Go. Then we had AlphaZero, which beat AlphaGo and started to broaden its capability to play other games, to MuZero, which actually shows a very exciting template for getting to broader AI, if we can call it that. It's not quite AGI yet, but the ability to generalize to multiple tasks, which has been a barrier across AI and deep learning, whereby we've had narrow AI, but multitasking has been a challenge in the way that a human or it could do. So the MuZero had the ability to learn how to play games itself without being given advanced information of the games in the way that both AlphaGo and AlphaZero had been given. So this is very exciting because we will be able to learn about these techniques and then apply them to situations outside of gaming in the way that DeepMind was able to apply AlphaFold, having learned about the gaming environments and then solve for protein folding. So this is going to have huge, exciting opportunities to apply as we go into this world, what I would call broad AI, which is in between AGI and narrow AI, and is something that David Cox, who leads the research at IBM Watson, MIT. And again, let's have a quick look in that area. We've seen exciting work coming out on something called Neuro-Symbolic AI, which is a combination of combining deep neural networks with good old-fashioned symbolic AI, and has been achieving big results on working with smaller data sets, but also giving explainability, because that's been a challenge with deep learning. One of the big challenges for deep learning has been its black box nature, and also the fact that actually we know it works very well, but we couldn't explain why it works very well. Nobody out there could actually tell you why. I mean, we can go through the design, etc. There are theories like the information bottleneck that researchers in Israel came out from and others, but we haven't come out with any conclusive, view yet. So explainability has been a big challenge as well when we come into areas like healthcare or autonomous cars. If something goes wrong, we want to be able to, the deep neural network, we want to understand, why did it make this decision to turn left instead of right? Or why did it classify this as cancer if it wasn't, or vice versa? So explainability and transparency is one of the big advantages that we can get with Neuro-Symbolic AI. On the deep learning side itself, we had also advances from the likes of Duke University, who did something called concept, the whitening concept, which kind of gave more light as to why a deep neural network was taking certain decisions with computer vision. It will be interesting to see if that gets transferred to transformers, if transformers, edge more and more into computer vision and take over that in the future. And then DeepMind also claimed that they could beat Neuro-Symbolic AI in the sense that matches performance and offer causality, which would mean that the likes of Yoshua Bengio could retire then, because that's one of his big aims, one of the leaders in AI. And also, but do it with 40% less data. Neuro-Symbolic AI was already reducing the data amount used. Now, the challenge there is that DeepMind unfortunately didn't release their code, which I think is a bit mischievous of them, because the likes of David Cox and the IBM Watson MIT team did release their code. So I think until we see the code there, it's hard to really adjudicate whether or not they've really solved for that. But in any event, it's been a year of real transformation, and hopefully next year we'll start to see the applications of these areas in the real world in exciting new opportunities. One final thing before I hand over to yourself and George has also been the rise in interest in areas like federated learning and differential privacy. It's still an area under research right now, but there is a lot of exciting work going on. There have been some deployments with TensorFlow Federated by Google, but the likes of PySift and OpenMind, who are also running work on this, are very much in the design stage, but hopefully in 2 to 3 years from now, especially as 5G scales and edge computing scales, we'll get a lot of opportunities to scale this in areas like healthcare, which will get around the data privacy and data fragmentation issues that we face in trying to scale AI across the real world and into key sectors like healthcare. There you go.
Thank you, Imtiaz.